So EIGRPv6 is naturally the IPv6 equivalent of what we saw with EIGRP in IPv4. So I'm going to take this from the standpoint that you should have a basic understanding of what EIGRP was and how it was used in IPv4, and we'll expand upon this a little bit to cover just the new changes or what's really different about EIGRP version 6. So the underlying architecture of how EIGRP works is pretty much the same as what we saw in IPv4. So it's still a advanced distance vector or a hybrid routing protocol, if we want to call it that. So it's a little bit of link state, a little bit of distance vector, but you kind of get the best of both worlds. So some of the things that we see with this, of course, like we did with IPv4, just kind of review, we're taking into consideration not only the hops that we have to go through, but also the actual bandwidth, the usable throughput, reliability, and those different K metrics like you saw in EIGRP version 4. So one of the big differences with this is that even though we still use hello packets to figure out who our neighbors are and are they still alive and what networks do they have, that process is still happening in EIGRP version 6, but we're using neighbor discovery with multicast packets. So all of that multicast traffic that you saw with EIGRP in IPv4 really stayed about the same. So hellos and those different acknowledgments and route updates, those all were broadcast over 224.0.0.10 in IPv4. In IPv6, of course, we see the FF02, so FF indicating that we have a multicast address. And you can see the very last block is the letter A, which is kind of interesting if you think about this. They did try to keep a lot of things the same, even though at the initial glance it might not look the same. But we know if we convert the letter A from hex back to binary, or decimal rather, we get the number 10. So kind of interesting to see some of those similarities, or what they actually kept as consistent as possible between IPv4 and IPv6. Now, one of the really awesome things about EIGRPv6 is going to be kind of like what you saw with OSPF. When we're configuring the router to have interfaces participating in the protocol, we don't need to issue the network command. And that was one of the big hanging points of EIGRP in IPv4 networks, is you had to know what your network block was, what the subnet was, be able to calculate wildcards, do the summarization, all of those different things. There's a lot of pieces in there, and it really forced you to have an in-depth understanding of what you were doing. So now I'm a type of person that thinks it's good, if you're going to go configure this kind of stuff, that you do have that holistic view of exactly what your network looks like, and what actually needs to be routed between these different devices. But of course, we always like to make things a little bit easier, take out some of that human error. So I do support the changes that they made in EIGRPv6, at least on the Cisco side of things. So we'll look at a few configuration examples and things like that, but just kind of hitting some of the highlights here in this video. So what we see with EIGRPv6 is we actually just go into our config T mode, hit the interface configuration, and just add them to be a member of that EIGRP routing process. So something that you do need to keep note of when you're looking at configuring EIGRPv6 is that if we're looking in the iOS Cisco world, some of the older versions you actually had to enable EIGRP. So they were talking like versions 12 and maybe older. I know it's fixed in version 15, or maybe fixed isn't the right word, it's updated in iOS 15. But you used to have to actually go enable EIGRPv6. And what this looked like was we would go into our config T mode, enable the IPv6 unicast routing, we would create our IPv6 router EIGRP, and then we'd have to issue the no shutdown command. So something to check if you are configuring this in the Cisco world, if you're on a little bit older version of the iOS software, just make sure that you've issued the no shutdown command after popping into EIGRP, and everything should be going after that fact. A couple other just kind of highlights here of what we need to be aware of in EIGRP is the router ID mattered in OSPF, and that's how we elected our root, or that designated router, which pushed out the updates, kept the network converged and consistent. The router ID in EIGRP can really be anything. It's not really as important as we once saw in the IPv4 versions. So you actually could configure the same router ID in EIGRP on every router, but maybe not the common practice we often see. But yeah, just some differences, some similarities between OSPF and EIGRP, but really what this was meant to focus on is just what do we need to change or adapt to make the v6 version of the protocol happen.